Actually, a couple of days ago, I was again in a cold weather. I was in Colorado, so still a little bit jet lagged. So if I say like wrong things, so be nice, please. Well, when I was invited here, I had like 3 questions. So I'm gonna ask quickly of this topic, and then talking about something about my research in more detail. So first of all, some like research issues. So mainly I think that it's interesting to focus on some kind of dialogue, not only between arts and science, but more in general between like abstract thinking and concreteness of nature. Because well, a couple of minutes ago, you were almost all looking outside, so it's a wonderful landscape. But at the same time, we can also investigate that landscape like in a more scientific way by considering light, temperature, trees, and whatever. At the same time, we can also be inspired by this landscape to compose music. Why not? And I'm also interested in developing new musical instruments, and like also looking for like a more stable job position in the research area. Within next years, I would like to develop some kind of interdisciplinary international network based in Italy, because there are plenty of Italian researchers like throughout the world. And regarding collaboration, I find like all people in this room like an incredible environment, because there are musicians, computer scientists, and so on. It's also very interesting to collaborate with experts in the field of natural sciences. Well, actually what I'm doing, I'm trying to connect things from different areas. I'm trying to use some concept of math, in particular of category theory, as like a universal key, a way to bring all of them together. And the reason why I'm doing the stuff, I'm like to investigate beauty. So it's hard, of course, to define beauty, but it's important because beauty is within nature, within the arts, and also within science. So actually I'm interested in exploring, discovering, connect, and of course communicate to the audience this topic. So in the rest of my presentation, I will just show a few examples of what I'm doing. Well, this was a very quick example. So, what about if I tell you that all the images in this picture have been created by using mathematics? They are just a graph of some mathematical equations. You can see like here, like revolution plot or some other parametric plot. And the music is improvised based on these images, but just to give you the idea of creating music and image at the same time. And I presented these graphics at the Mathematical Art Gallery of San Diego just like last week. Well, just as a little homage to Austria, I was inspired by this amazing structure. I did not compose music on it yet, but I just would like to talk about how can we investigate. So, first of all, we can think not only about like the general envelope of the structure, but also as a pattern. And within this pattern, we can isolate just one single element. And within the single element, I don't know if it's so clear to see, we can try to draw. Draw what? Try to extract some simple essential lines. So, as a form, we have a group of leaves. The overall geometry can be considered as the half sphere. We have a color, we have a material, so we have a lot of data, and we can try to map this data into music. I'm not giving sound here, but we can imagine the W just like some technical problem from to the conversion to PowerPoint. So no like hidden meaning behind this W. So you can imagine this one as like a melody, this opening and closing, and then we have a repetition as we can have a music. another repetition, so this will be our theme, and we can repeat this theme. So we can imagine to have like different instruments in the orchestra, different time, and so on. And so creating and going, no. So like creating and making like a tiling of this half sphere. It's just a suggestion. So these are some of the images of the former graphics I shown, and these are just the parametric plot. This is just a very simple plot. As you can see here, there are the equations. But by changing a little the parameters, you can see we can get like a shell, something that is like a fish, or some algae, and so on. So the idea is that we can investigate forms from nature, for example. We can extract some essential forms, and we can also make comparison with music, as I will explain just in a second. So, well, maybe there is not apparently a lot of art here. We have here some parametric equation. We have some transformation. This is bringing this one into this other one. This is a commutative diagram, so we can have different paths. But if we forget about that and we make the graph, we see again the shell. So we can forget about this transformation, just use this transformation to connect this form, one into the other one, into the other one. In this way, we can navigate through the variety of nature by using like simple shape variations. It's like music, where we can, for example, compare a theme from a piece with a theme from another piece, music style with another one. So it's just somehow a similar way of thinking. This is just an example, so we can move from this other shell, and I can compose this arrow together. So as in music we have composition, also in math we can like put stuff together somehow. So considering first this arrow and then this other one, so the overall transformation is given by this arrow, and this is the transformation corresponding. And if we go, we make a little bit of coding, we actually can change. As you can see here, we change this parameter and magically the shell is changing. Okay. Cool. We can move forward this way of thinking by considering some other forms. These are some poems, and what I'm doing here is trying to compare this young poem with this growth one. This is Butia Capitata and Coccotrinax Argentea. I just forgot to put down the names. But also we have the growth of this other poem. But we can compare the form of this one with this other one. We can compare species. And we can also compare the growth processes. In the same way, we can analyze musical pieces. For example, comparing a musical sequence of a piece with a musical sequence of another one, or just like a theme of a sonata with the second theme, and so on. And we can, of course, also compare the development musical pieces. So how the composer is dealing with this theme. By the way, this is already math, because this way of thinking, by using this diagram, this mapping of arrows and arrows mapping into arrows or whatever, are part of the language of category theory. There are some properties, verified, and so on. So it's just a way of thinking. So, of course, a poem is not a musical piece, but we can compare the way of transforming visual and musical material. Another example regards this pangolin. That is quite interesting because, as you know, this is the shape of the pangolin. When it is scared, it closes into a ball, and we can imagine to create this shape by using sequence of transformation from a single scale to a musical scale, maybe. So like drawing this line, this profile. And we can apply visual transformation. At the same time, we can apply musical transformation. So our attention can shift from the image and the sound to the transformation applied to the visual and the transformation applied to the sound. as you can see, is like somehow a process of composing music, because we can start, for example, from a theme, make some transformation, and change the material. So actually you can wonder what could be the common denominator between sounds and images. So there can be a lot of possible answers. My own answer was this one. So if you consider movement, so this movement can make us thinking of a staccato. So if you're playing piano, playing violin, or just conducting, people will perform a staccato. With this movement, people will think of a more legato. The same stuff, you have a pencil. You can make like dots like this way, or you can make more continuous lines, is the other side. I call this one gestural similarity. As you can see, we can compare images and sound as thinking them as being generated by similar movements. Some other examples can be about flowers. I love these flowers. I took this picture in Japan because there is a clear geometry here. So we can imagine a process transforming like a closed flower into an open one. So our transformation is this one. We can map each flower within a sphere of flowers, and we can compare this shape with this another shape. This is a sphere that otherwise an ellipsoid. This does not exist, so don't look for it. There's not. We're just like an idea. We can also define over there the process of opening of the flower, and we can make a cross comparison between this creation, this other one, and this transformation that is called alpha, is called a natural transformation in category theory. So we can make this very abstract cross comparison. And for example, for flowers and shapes, we can make music, why not? Because we can associate notes to this image. We can compose, we can map, we can make whatever we want, but we can give this idea like erasing and lowering and repetition. And we can create a sphere of musical flowers. For example, by choosing, like associating some parameters, for example, timbre and overall pitch variation. So we can give the idea, of course, this is a choice. We can have different choices, but we can try to give the listener the idea of like a surrounding sound, somehow a sphere of sounds. Again, I wrote down a little bit of code, and again some code here, just to make the sphere, some code, and this is the result. And so on. And we can think again of the initial shape, because if we can make music out of that, maybe there will be some similarities with this sphere of flowers. Just the last thing, the cube harmonic. This is a different topic, but still one of the topics of my ongoing work. This is a Rubik's Cube with some musical notes, and you see here the version 4x4x4, just maybe the so-called revenge cube. And the initial idea was to put a chord here, a chord, and again like 1, 4, 5, 1, and here other chords, other music styles, and so on. Once we mix the cube, we mix the musical sequences. And I got this idea because actually I never been able to solve the cube. Do you able to solve the cube? Oh wow. Thank you. Well, I was not able to solve it, but well, maybe we can play it. And I made a very first prototype. I got this idea when I was at IRCAM. I made the first prototype when I was in the US. I bought like the giant cube because I did not find like smaller audio modules. Yeah, there is another version, the prototype, that is under development with the RIEC Institute in Japan. It's an institute to research in electrical communication. They are not making musical instruments, but they are making motion tracking systems. And by applying, as you can see maybe here, there are several, this is a system that is generating a magnetic field. And within the cube, there are motion markers that are making some interference with this field, so we can track the position. The computer knows where the pieces are, and it can play the musical sequences. This is just an example. Well, thank you for your attention, and this is a book with some of the information in my presentation. Thank you.